Look at your hand right now. That color, whatever shade it is, did not fall out of the sky. It was not painted on. It was fought for over 100,000 years in a war you never knew your ancestors were fighting. And the enemy in that war was the one thing you can never escape, never negotiate with, and never turn off. The sun. 93 million miles away. And it still had the power to decide who lived, who died, and who got to have healthy children. Today we are answering the question everyone thinks they understand, but almost nobody actually does. Why did ancient humans go from black to white? And I promise you, the real answer has nothing to do with what you were taught in school. Here is the part that breaks people's brains the first time they hear it. Every single human being who has ever lived traces back to one dark-skinned population in Africa. Not most of us, not the majority, all of us. 300,000 years ago, when Homo sapiens first showed up, there was no such thing as light skin anywhere on Earth. Every ancient civilization you have ever read about, every myth, every king, every pharaoh, all of it descends from people who looked nothing like a huge share of humanity today. So somewhere along the way, something changed. And that something is one of the most elegant survival stories biology has ever produced. Before we get into it, quick favor. If ancient history and human evolution genuinely interest you, hit subscribe and join Half Evolved. We take these stories seriously, and we dig past the surface-level explanation everyone else stops at. Okay, back to the equator. To understand why humans changed color, you first have to understand what skin is actually doing. It is not just packaging. It is your largest organ. And one of its most important jobs is defending your DNA from ultraviolet radiation. UV light breaks chemical bonds. It damages DNA directly. Enough damage in the wrong place, and you get cancer, specifically melanoma, one of the most aggressive cancers that exists. Melanin, the pigment behind skin color, is a built-in sunscreen. More melanin means darker skin, and darker skin means better protection. In equatorial Africa, under some of the harshest UV radiation on the planet, dark skin was not a preference. It was the price of survival. But there is a second, far less talked about reason. Dark skin was so essential, and it has nothing to do with cancer. It has to do with pregnancy. Your body carries a nutrient called folate, a form of vitamin B9, and it is critical for something called neural tube development in a growing embryo. That is the structure that becomes the brain and spine. Without enough folate in the earliest weeks of pregnancy, often before a woman even knows she is pregnant, the neural tube can fail to close properly, leading to severe birth defects or miscarriage. Here is the problem. UV radiation destroys folate in the bloodstream. In a sun-soaked environment with no clothing and no shelter, lighter skin meant more UV reaching the blood, meant more folate destroyed, meant fewer children surviving to be born at all. So evolution had two independent, brutal reasons to lock in dark skin across the entire species. It protected DNA from cancer, and it protected folate for reproduction. Under the African sun, dark skin was not just good. It was mandatory. So if dark skin was this perfectly engineered, field-tested, 5-star biological shield, why did it ever change? The answer starts around 70 to 90,000 years ago, when small groups of humans began drifting out of Africa. Nobody planned a migration. Nobody called a meeting. Stop. Families simply moved a little further than their parents had, generation after generation, until humans had spread through the Middle East, into Europe, across Asia, and eventually the Americas. And as they pushed further north, the sun itself effectively grew weaker. Not the sun, but the angle it hit the Earth at. At high latitudes, sunlight travels through far more atmosphere before it reaches you. Days shorten. Skies stay gray for months. The relentless UV of the equator became something faint, filtered, and scarce. And suddenly, the greatest survival tool humans had ever evolved became a liability. Not because of cancer. That risk dropped along with the weaker UV. The real danger was vitamin D. Your skin makes vitamin D by using UVB radiation on a compound just beneath the surface. It is essentially a solar panel, and vitamin D is not optional. It controls how your body absorbs calcium and phosphorus. Without it, bones stop mineralizing correctly. In children, this causes rickets, a disease that bows the legs and deforms the skull. In women, it can soften the pelvic bones so badly that childbirth becomes deadly. Vitamin D deficiency also weakens the immune system and undermines muscle and cardiovascular health. Now picture a dark-skinned population transplanted into Northern Europe. Their melanin, brilliant in Africa, is now blocking the very sunlight they desperately need. Their bodies cannot tell the difference between UV that threatens them and UV that could save them. It just blocks everything. Vitamin D synthesis collapses. Bones weaken. Childbirth becomes more dangerous. Populations start losing children they cannot afford to lose. And evolution, which does not care about tradition or appearance, only about what keeps people alive long enough to reproduce, began quietly selecting for less melanin. For decades, scientists assumed this depigmentation happened slowly and steadily over tens of thousands of years as people spread north. Ancient DNA has completely overturned that idea. Take Cheddar Man, a hunter-gatherer who lived in Britain roughly 10,000 years ago. When his genome was sequenced, researchers found he likely had dark to medium dark skin, dark curly hair, and strikingly blue eyes. A combination that looks almost contradictory to modern eyes, because we associate blue eyes with very pale skin. But 10,000 years ago, that link had not formed yet. The extremely pale skin common across northwestern Europe today appears to have spread widely only in the last 6,000 to 8,000 years. In the full 300,000-year story of our species, that is barely the final 3%. So what actually triggered this rapid, late-stage shift? The Neolithic Revolution. The switch from hunting and foraging to farming rewired human diets almost overnight. Hunter-gatherers ate fatty fish, organ meats, and shellfish, all naturally rich in vitamin D. Farmers ate wheat, barley, and other cereal crops, almost none of which contain meaningful vitamin D. Suddenly, entire populations were relying almost completely on their skin to manufacture a nutrient their food no longer provided. Even a small amount of remaining melanin became a serious liability. On top of that, farming communities were larger, denser, and more interconnected than scattered hunter-gatherer bands, which meant a beneficial mutation for lighter skin could spread through thousands of people in just a handful of generations instead of tens of thousands of years. Diet collapse, plus population density hit the fast-forward button, and the pale skin we associate with Northern Europe exploded into the population in a geological blink. Here is something that genuinely surprises most people. There is no single gene for skin color. It is controlled by dozens of genes working together. Genes like SLC24A5, which act like a dimmer switch on melanin production. And different populations arrived at lighter skin, using completely different genetic routes. East Asians and Europeans both evolved lighter skin than their equatorial ancestors, but largely through different mutations. This is called convergent evolution. The same solution discovered independently, more than once, by separate populations facing the same problem. When evolution reinvents the same answer from scratch multiple times, that is about as strong a signal as biology ever gives you that a trait genuinely mattered for survival. While we are here, one more genuinely mind-bending fact. Every blue-eyed person alive today descends from a single individual who carried one specific mutation somewhere near the Black Sea, roughly 6,000 to 10,000 years ago. Before that person existed, every human on Earth had brown eyes, all of them. That mutation, something we now treat as an ordinary human trait, is younger than farming, younger than Stonehenge, younger than the domestication of the horse. So let us step back and look at the full picture. Skin color, the single physical trait that has been used to divide, rank, and oppress people throughout history, is at its biological core nothing more than a UV calibration system. A dial, tuned by your ancestors' latitude, their diet, and the intensity of the sun they lived under. Light skin is not an upgrade. In equatorial regions, it is genuinely dangerous, more cancer, more folate destruction, lower reproductive success. Dark skin is not primitive or unfinished. It is the ancestral original human condition, the baseline every other variation branched off from. The same sun that forced some populations to build more melanin for protection forced other populations to shed melanin for survival. It never picked a side. It simply radiated, indifferent, and let evolution work out the consequences across 100,000 years. And every continent on Earth, we built entire hierarchies, entire systems of prejudice on top of what is ultimately a vitamin D problem and a folate protection mechanism. And the story is not finished. Human populations are still evolving today, slowly, up, almost invisibly on any single lifetime, but the underlying mechanism never switched off. Even if sunscreen, supplement scents, and fortified food have quieted its pressure. Every shade of human skin walking around this planet right now is a written record of a journey, the same African population spreading into an unpredictable world, and carrying, in melanin, the precise history of every place their descendants ever called home. Every skin tone is an answer to a question asked by a star, and every single answer was correct. What part of human evolution should we cover next? Tell me in the comments. Stay curious.